this is Ganesh and I'm studying in second year MIS. Today we are going to see about a case study on Tesla Autopilot, which we will concentrate on the design architecture, design software, design quality and its attributes. What is Tesla Autopilot first of all? It's an, you already know it's a driver assistant automobile one. It is a semi-autonomous one which is fully autopiloted. It will like you already know Tesla cars which are autopilot is like it will self-drive. No need of a driver to get into the driver's seat and drive it to the location where we want. We just have to enter the GPS location, give it to that. It will automatically track its own way. It will just see the surroundings and go. We'll study about its design attributes now. See, actually the goal of the Tesla mobile autopilot is to have a good safety journey and convenience, efficiently dropping the customer, making the customer happy, to reduce the work of the drivers like jobs, everything, to give us advanced driver comfort to the customers. And the key components are this is the hardware suite. Hardware suite is like Tesla is a autopilot Tesla car is not that easily can be manufactured. Its hardware must be clearly designed and it should be perfect such that accidents are not occurred. It is reaching to the correct destination. Its hardware will be very complex for us to understand. Like it will have the cameras, radar, ultrasonic sensors in it and powerful onboard computers. These sensors will provide the vehicle surroundings enabling autopilot to detect objects. It will detect whether there are any objects or not. It will navigate us to our destination. And computer vision algorithm, whether the path where we are going is correct or not. When we are parking, it will just check the where you have to park, whether we are parking it correctly or not, whether it's crashing any other car or not, whether we have to take any direction or not as the autopilot itself. And machine learning models are very important because only when the machine learning algorithm is correct, it will run perfectly, like where to stop, where to halt, it should have check the signals, it should take diversions, it should check on both the sides such that it is not crashing anyone, whether it have to check whether the customer got in and sat comfortably or not. Neural network also includes the same. It will keep the vast amount of data in it. Neural network helps in data like data of navigation, data of brake system, data of all the sensors and everything. Coming to the sensor function, yeah, where if the sensor function fails, the Tesla autopilot will crash cause it doesn't crash but accidents will occur more. Next, coming to the architecture principles and attributes, it includes modularity. Obviously, modularity is too much understood. The Tesla's autopilot invention must be taken in modules such that if any one module fails, we can redo it, and at the same time, if any upgradation is required, we can update it easily. And then scalability, such that scalability is future, whether it's success in future or not, whether if any integrated extra additions are needed to be done, everything. New features are developed, then it should be integrated obviously. Coming to the redundancies, multiple levels to enhance the safety and reliability of the Tesla cars. Then coming to real-time processing. Real-time processing is decision making and response. It should while a sudden situation occurs such that a man came in front of the car all of a sudden from nowhere, then the car must be able to take the decision on its own, like hitting on a brake before the code runs and tells you to put a brake. Like spontaneous reaction is required. For that, real-time programmings will be inserted into that. Processings are also inserted in that. Continuous learning, it should learn continuously, like upgradation according to the technology it's going now, and it should give a good performance, accuracy. It should enhance all the programs, all the upgradation will enhance the efficiency and safety of the Tesla automobiles. Coming to the cognitive dimensions, we already know there are many cognitive dimensions. Few I mentioned over here, like visibility. The visibility must be there. Consistency, error proneness, there shouldn't be an error in the design. If any design is having an error, it will obviously accidents will occur. The first thing is humans will lose hope in that item and it will no longer be used in the society. Next, hidden dependencies must be there on the condition of road marketings, everything. All these shouldn't be known to, few things shouldn't be known to the customers, few things must be known to the autopilot cars, Tesla cars, and cognitive overhead, etc. Next, coming to the developing attempts, this tells about the development of how the Tesla developed the autopilot. First one is like introduction, how when they introduced this model in 2014 with the initial basic model of Tesla car, including the autopilot. After that, they later upgraded, like they expanded. At 2016 to 2017, they went into detail and a little depth, and they added few more machine learning integrations and path planning, own decision taking, everything, sophisticated algorithms were inserted into this. And after that, in 2018 and 19, enhancement was done. Like enhancement here comes to be clearing the challenges that occurred until then by adding extra modules, upgrading everything. Full self-driving beta was 2020 they released, but to overcome all the challenges, everything, and successfully run, it continued its development and had got into many iterations to get a successfully running present Tesla autopilot cars at 2020. From 2021 they started this, and the present now also in many countries is getting autopilot cars are running, Tesla's autopilot cars. Next, coming to the main challenges, people accepting it. All of, even when you got into a sudden invention is made and you are tried to go into that and travel in that, you are not going to travel. Obviously, it needs some hope. But for the first time, if I want to get into autopilot car without no driver, I would get afraid in the start. Like, what? There is no driver. How should I get in? Is there any, like, are you sure that it's gonna work or not? Everything, all those questions must be there. Society, technical limitations, whether they have the correct machine learning programs or new developed programs, everything, cyber security, whether it is hackful or not, it is like it should be ethical, and the firewall must be created so well that no other person should hack into it and drive the cars around instead of getting into the destinations. And many other regulations, public risk perception, regulatory approval, whether no one is going to approve that so soon. It should pass into many processes, steps. They'll check the design, its design architecture must be good. They have to pass all the tests such that it is left into the society. Coming to the conclusion, despite all the challenges and everything we talked about, this successfully ran and is now completely running in the society, giving us success. It was a very long journey of that being developed. So that's it. Thank you.